The last trend we're going to be looking at in this chapter is metallic character. And it's the only trend in this chapter that you cannot look up on table S. This is just something you need to know, and it's pretty obvious, and I'll show you how we judge metallic character. Metallic character basically judges how metallic an element is. We're basically ranking metallicness. So remember the staircase that borders the line between the metals and the nonmetals? All the metals are to the left and the nonmetals are to the right of that staircase. So what are the qualities of a good metal? So metals have low electronegativity and low first ionization energy. So low electronegativity means they're not going to steal other electrons. In the tug of war for electrons, they always lose. They give up their electrons to nonmetals. So therefore they have low first ionization energy. It does not take a lot of energy to remove an electron from a metal. So the metallic character of an element can be defined by how readily it will lose electrons. So when you're judging two elements to see who has a greater metallic character, you need to ask yourself which one of these is going to lose electrons easier. So let's look at the group and period trends. As you go down a group, the metallic character is actually going to increase. And that's because the electrons are in the outer shell are further away from the attraction of the nucleus. As we go down the group, we get another shell each row down. Also, there's more shielding, so the electrons in the outer shell aren't being influenced as much as the electrons in the core shells. So therefore, they're more likely to lose electrons. So as you see, as we go down group 1, francium is the most metally metal on this group. And you can judge this when you throw these metals in water, actually. If you throw lithium, sodium, potassium, rubidium, cesium, and francium in water, as you throw each metal in water, the explosion, the reaction you get is going to be greater each one you go down because each atom is losing its electron faster in the reaction. The period trend is even easier. So the period trend should be kind of common sense to you. As you go across the period, the metallic character decreases. Well, that should make sense because as we move across the periodic table, we transition from the metals to the metalloids to eventually the nonmetals on the right-hand side. But the reason is, as you move to the right, there's an increase in nuclear charge. So the greater nuclear charge you have, the more electronegativity you'll have. Also, the more likely you are to take electrons and not lose electrons, which is what we're judging metallic character by. So remember, as you go down a group, metallic character is greater because each element has more shells and less electronegativity, so they're more willing to lose electrons. And as you go across the period, metallic character decreases because each element has more positive protons and a greater electronegativity, so they're less willing to lose electrons. So this last chart here summarizes the metallic character trends on the periodic table. So the metallic character increases as we go down and it increases as we go left.